Welcome everyone. Another live stream for Nim and Unreal Engine. Unlike the previous live stream, this time I have some kind of plan that will guide me, will force me to do things in a specific way, okay? So the previous live stream, we just, figure out how to install, how to set up the project, and how we can create like a simple blueprint library. We figured out a lot of stuff. I guess I'll be referencing those notes a lot today. So for today, I'm thinking maybe I could take one of my, probably like 8 years old assets from the Unreal Engine, Marketplace that was like blueprint only. And I could try to start converting it to, or like transferring it to the Nim language, just to learn all the things, about dealing with components, with some basic inheritance, with structs and classes and a bunch of other stuff, and see how much we can figure out how to do it in Nim. And this way, this will teach me a little bit of what Unreal Engine worked like, because I don't remember anymore. I just bits here and there. So I can move this thingy here. Okay, and I'll show the screen so you don't have to keep looking at my face in the close-up. All right, so if I'll go to search for easy interactions, okay, that's my old project. I can probably show it here. Yeah, it started with an Unreal Engine 4.10, so it's a little bit old. Yeah, I don't know if the YouTube link still works. Yeah, I already deleted that, so yeah, because it's not available on the marketplace anymore. I just have it because, I made it, therefore it's as if I purchased it. So it says add to project. Okay, so let's do it that way. We're gonna go to, I already downloaded the latest version of Unreal Engine that supported it. It was 4.26. And therefore, I'm gonna launch it and we can figure out, how to create a new project and see what happens. Oh, it's the first time I'm turning on Unreal Engine. Let's hope it's not gonna take 30 years. Come on, what are those installation steps? Can't move the thingy. It's loading, 45%. Alrighty, come on, Unreal Engine. Yeah, the new Unreal Engine 5 seems like it actually loads faster and everything. Okay, oh wow, that's a throwback. I forgot it looked like that. So let's say that we're gonna go with a game, and it will be a first person because that's what the template was using. Next. Oh wow, yeah, that was blueprints only. Sure, retracing was already supported in 426. Okay, disable desktop console with starter content. Yeah, we're gonna do all that. I'm just gonna place it somewhere else. In Unreal Engine. Let's do sure name, and it'll be easy interactions old. Okay, we're gonna place it there. Easy interactions old. I guess I could just do it like this and it should figure it out, right? Create project. And let's see. Oh, it opens up on the other screen. So bear with me. There we go, the old Unreal Engine. I'm sure it's still in use. Oh wow, that looked bad. Holy moly. And I remember being amazed how amazing this looks. Oh dear, can we play it? And big buttons back there. Yeah, we can play it. Okay, that I don't know why, but now it looks like Unity engine. Oh yeah, the screen space reflections and all that. Okay. So we have our project. Now we should be able to go and add easy interactions to it, right? So where did it go? Easy. I will go easy interactions, add to project, add to project. Well, it's only 65 megs. I recall a lot of work just to make it small. Is that it? Let's see. Blueprints. No, that's all here. Maps. It's still there. Okay. Oh, there it is. Easy interactions. So let's see if I can just... if it's gonna just work, or do I need to do some other stuff? Compiling shaders. Another thing that you see less and less. Okay, let's give it a moment. I'm gonna set it to not be real time while we're doing stuff here. I'm just gonna make it a tiny bit faster. Okay, we're nearly set. It's not bad. Okay, wow, that was quick. So let's see if I can start a project and show you what it was about, therefore what we'll be building, okay? Can I play it? I can, and it works, jumping and everything. Okay, so what is it, F11 or something? Yes. Sure. Yep, you can see the screen, awesome. So let's read my old English. That's from a long time ago. The easy interaction system makes blueprint communication faster and easier to implement, more unified and very flexible. It can be useful in small as well as in big and complicated projects where changes are expensive. Yeah. So yeah, we're going there. So basically, I'm going to go through it because I don't remember how that library worked exactly myself. And if we want to understand it and replicate it, we need to learn it. So yes, there was a concept of signal transceivers. Signal transceiver component is the most important component in easy interactions. It allows for receiving and transmitting signals between other blueprints that contain signal transceiver component. So already the very important part of, information, whatever, is that basically the whole idea of these interactions is that you don't have to write your own specific interfaces for things. You have this component that you can slap on and make things compatible, okay? So sending and receiving. And when you step into the trigger box, it's here a little bit, I don't know how well you can see it. It sends name signal to the lamp on the right. And the lamp blueprint signal transceiver component will receive name signals and fire the unnamed signal event. Okay, so I step into it and lights up. So let's look at it in the engine. So we have this little object here. And that's a blueprint, right? Edit blueprint. Let's see what it looks like. So in our event graph, we have literally it. Those two things. So, gosh, it's going to be tiny on a live stream. I hope it's visible. So let's see. We can see that we have a component named signal transceiver. Okay. And does it have any settings? Just a name signal transceiver, category, just default and all that stuff. And easy interaction signal, on signal. Okay, nothing here. Component tick, whatever, doesn't tick, all that. Okay, so that's it. You just slap it on. All right. And here we can basically have on component begin overlap and end overlap. Okay. When it begins overlapping, we trigger from the name signal transceiver, we trigger transmit signal. And we just target as receiver. Huh? What is the receiver here? Receiver. Actor object reference. Current value. The wall lamp. Oh, right. Because I need to then in the editor actually connect it to the other one. Okay. So it targets some kind of receiver, which is actually, a target is just a variable here, or whatever. Yeah, just a variable of type actor. And data to transmit, which would be on trigger message, which is just name. Okay. So I'll just send that name to that lamp, and bam. And when it's not overlapping, we just send a different message, the off trigger message. Okay. So let's look what it looks like here. So when we have it selected on the right here, we have the target specified, and it just points to the signal transceiver lamp. Okay, which is this guy. So yeah, I could simply, click something and click the other actor and we'll just pick it. On message will be on, off message will be off, and that's it. We're just sending a message on or off. And in the lamp itself, we don't have anything here. Everything is in the blueprint, right? So let's open the blueprint and it will look very similar. We have just name signal transceiver component, and we have the received name signals. So it's on signal, which is for receiving signals. The received data, which is just name. It's just for name signals. And we switch by name. If it's on, it's this. If it's off, it's that. And we have also support a third signal, which is toggle. Okay. So that's it. You just receive it here and do something with it. And that's all it is. And all that here is just for fancy flickering and whatnot. It's just not part of the actual thing that matters. So yeah, that's it. Okay, that's actually surprisingly simple. So notice that we have something called name signal transceiver. So it's an actual type name signal transceiver. That means that we have different types of signals. Okay. Can we resume from here? Not really, but we're already here. So yeah, when we step in, lights up. When it's off, lights out. Okay. And so let's see, signals. Signals are chunks of information that can be sent by signal transceiver components. There are various pre-built signal types, each containing different data. So we can send void, which is nothing. It's just a message that something was sent, and that's it. Bool, integer, float, string, vector, rotator, transform, actor reference, object reference. So you can basically, send a whole actor, send a whole reference, and, some, interaction, whatever that is, name or actor class. So the thing I remember is that all those are separate components, separate classes, okay? For specific types of signals. That's what I remember now. And then we have transmit functions. For every signal type, there are a couple of functions to make transmitting easier. You can do transmit and the type, right? Send signal, transmit type as, send signal as provided actor. I guess you could pretend that something else is sending it, right? Because I can imagine that, you might want to have one logic for sending, but depending on which player it is or whatever, you want to do something else. And multiple in pairs of signal data and target actor. Okay, so you can send it out to multiple targets. And pairs of signal data and target actor. In addition, it sends those to as provided actor. Okay, that's simple enough. What else do we have? Trace interactor. Oh, that was the fun part. Trace interactor component is designed to be added to player blueprint, constantly shoots traces and looks for actors with direct interaction component. When interact function is called, it sends interaction signal to the pointed actor. To make trace interactor component work, you need to add it as a child of camera. It shoots along x-axis of the component. Additionally, trace interactor needs signal transceiver to work properly. So yeah, this is basically the thing that slaps onto the camera, and whenever you're looking, wherever your cursor is looking, it's, the ray that hits, and you can basically target something. So that's the idea here, and therefore we can just walk up to something, and I guess direct interaction component makes blueprint react to messages from trace interactor. In addition, it requires standard signal transceiver component to work. Press E to switch on switch to interact with it. So I press E, and that interacted with it because it's being targeted by that trace interactor. Okay. Yep. That's all this. And again, each press of the E is just that signal from easy interactions. So interaction signal. Interaction signal contains data. Okay, so interaction, that's the specific interaction signal. Okay. Contains data like receiver when transmitting, reference to actor that should receive the signal, sender. Okay. It can be altered using as function, because it's often that you want, something specific to be marked as the sender. Interaction type, which is enumeration used to decide what to do with the signal. To add interaction type, edit the interaction type. Okay, so you basically have an enum with all the possible interaction types, so that you can specify a bit more. And interaction start used to check if interaction started or ended. Okay, so that's it. Filtering interactions, creating blueprints that player will interact with. You may want to filter interactions to specific meshes. And trace director component, you can check filter by tags checkbox, then add tags to the component, and add tags that component will be looking for in trace components. That could be rewarded. Then in interactive blueprints, add tag to every component that you want to be interactive. So for example, look at the BP door. The frame is disabled for direct interactions. Only the door itself will interact. Yep, so simple, filtering. Mask component. Oh yeah, that was a fun one. Mask component is a simple component to enable blueprints to mass weighting. What is that wording? I mean, it can pretend that, it can basically weigh something. Cube on the left has mass component. Pressure plate on the right reads mass of colliding actor and reacts to it. Also, player blueprint has mass component, so it is detected by pressure plate. So when I walk on it, there's no actual collision here, other than, I don't know, some basic detection. But it checks the mass, and player is marked as heavy mass, therefore, it lights it up. Okay, the same thing here. We can just push it. And there we go. It's pressed. So, yeah, it's kind of fun. And name receiver pairs. That's another thing. You may have noticed that in most of example blueprints, the name receiver pairs to send signals between them. STC name receiver pair. Structure is used to simplify sending name signals. It is used mainly as an array variable made editable to enable quick selection of target actors and name signals transmitted to them. Okay. Okay. I guess that was my solution to just have, that I can specify a bunch of stuff. All, like quickly have an array. Let's see if it's somewhere here. Like this thing here. Does it have it here? Setup, enabled, activate targets, and we have 2 members. Oh no, just one, and that's probably the deactivate targets. Okay, so which targets? So I can edit it, and it should be here somewhere. Setup, activate target. It's an array of STC name receiver pair. So the whole idea is that I can make an array of that. And it would just show up as something that, a name to send and a target to pick. And I could easily just add another one that I want to send it, I don't know, to somewhere else, okay? So that's the whole idea here. Away from current camera location. There we go. Let's continue with this thing. We're nearly through, I believe. And then we have HUD message viewer. That was very basic. HUD message viewer component is intended to be included in player blueprint. Attached to the camera, it is used by other blueprints to display messages on player's screen. This happens through direct interaction component. Okay. And here's an example. Pressing on door. So I walk up, and when I walk to it, we can see that it shows open. And notice that the frame doesn't show up. Even though the frame is part of the blueprint, the frame doesn't have the tag to interact with things, while the door itself has. So I can press E, and it opens and closes, and I can't interact with it in the middle, and I believe that was intentional. Yep. Gosh, I missed those old template doors. Okay, let's continue. Oh yeah, we just have this showcase of a few things. So blueprint examples. So the whole idea was that I can make few various little blueprints using the system, so I can kind of dissect it and see how it works. And it was also a way for me to, test it if it actually works. So a simple switch, right? You can switch it on and off. That's it. And this one was, you switch it on, and when you switch it off, it toggles this one. When you switch it on, when it goes down, it toggles the lamp to the left, and if not, on the right. So let's see. We have this thing here, right? Let's see. Activation targets. We just have the wall lamp 3. While deactivation target, it sends toggle to wall lamp 2. So that's how it works. Well, this one will probably send on and off, right? On and off to the same wall lamp. Okay. Cool. Switching switches. Oh yeah, that was another thing. You can just make the switch to also receive a signal, not only send, but also receive a signal. So I can press this guy, and they all send each other a bunch of signals depending on what's being, sent and received, and they just react, and they're just in the forever loop right now. And I'm sure we can stop it somehow. Stop. But that's the whole idea. You can just link them together, and they would just keep triggering each other. So it's possible. Then we have button customization. So this was like a dimmed button. You can press it. Okay. You have this one. I actually made it so it lights up and whatever. It lights up when you start targeting it, okay? And, a bunch of colors, whatever. Parameters. And you can press them, they do their job. And then buttons can have uses limit. So that's another thing you can just keep adding. For some reason, I really like making a button. This was 1-time use. This one is 3 uses. 1, 2, 3. Okay. And this one has reset button. So I guess this button will send a signal to both of those buttons. Something like reset. Bam, reset. Okay. So if I'll go here, we can see that it's enabled, uses limit 0, target 2 members, reset uses for one and reset uses for the other one. So I might as well just copy it, right? And say that only for this one I'll reset it. So I'll remove this guy here. How do you remove it? Delete. Okay, it should reset only on the right. So when I play it, and I use this one up and this one up, and I press here, only the one on the right did. So that's how easy it is. That was the whole idea. When you learn the system a little bit, it's so easy. Oh wait, what's the shortcut to play? Alt P. Okay. Sure. So then button can be disabled or enabled, right? Enable button, disable. Okay. So again, just sending stuff. No big deal. I made some example doors. There we go. Then we have this one that opens a little bit. This one that opens real slow. And this one that opens the other way around. Yep, just configurable door. Why not? Then we have can be locked, unlocked, open, close. So that's another example of usage of it, where you could just simply, now door can open and close it, right? But you can also, what is it? Oh, that opens, or switch the other way, closes. And this will probably lock it. Yeah, it shows locked. So just send a locked signal to the door and the door will handle it. And that's it. And the thing is that you're just sending signals, and however you store the variables, it's up to you. So replication, whatever, it's up to you. Totally up to you. Nothing needs to hold some specific state here. You're just sending signal whenever you want. And what matters is connections. And signal delay blueprint. Delays received name signal. Yep, that's another thing that you can just do. Like you're gonna press the switch with 3-second delay. Press. And bam. Switch, okay? 1, 1, 2, 3, 1, 1. 1, 1, 2, 3, 1, 1, yeah. And here's press the switch with 3-second delay and limit of 5 signals in queue. Wow. So you should only do 5. 1, 2, 3, 4, 5. Because the 6th one was already too much in the queue. Okay, and spawner blueprint, spawn provided actor. Yep. I can keep pressing and spawning. Fun. And logic gates. Oh yeah, I even implemented basic logic gates, so you know, like you need to press this switch. Oh. Oh, like this one automatically opens or whatever. Or, oh, that was like a little puzzle. I need to figure out how. Oh, wow. I didn't expect that I'm gonna get it on the first try. And that was the most elaborate one, where you have, you know, add impulse energy to flywheel, you know, simple thing like that, and you can just keep pressing, and all those things turn on and off depending on the blueprint. They're just sending each other signals. And the good part is that the only thing that binds those together is that you have reference to an actor, which you can, you know, do during runtime, and a text that you're sending or whatever, a value, rather than actually, you know, having reference to a different actor and calling things on it. So you have that separation. So yeah, that was the main idea here, and now we just need to dissect it and see how we can re-implement it in Nim. Yeah. So where do I start? So let's look at what we have inside here, because we have demo room. Yep. We have maps, materials, meshes, and textures. We don't care about any of those. What we care about is blueprints. And with blueprints, we have, you know, we have the button, we have the door, the flywheel or gauge meter, logic gate, which just looks like that. Oh, okay. Look how cute it is. I made a little texture back then as a kid. Scales, yeah. Switch and wall lamp and weighted cube. Yeah, all that. So these are our examples that we can, you know, try to re-implement at some point. But what matters more here is we have libraries, signals, and sys. I guess the internals, the core, where we have 3D widget, some macros, HUD select message, direct interaction component. Okay. Logic gate type. Again, HUD message viewer, mask component, and trace interactor. Okay, so these are like, you know, more fancy stuff. I want more core. So we have signals. Okay, all the transceivers are here. Okay. And I believe I had like a base transceiver or something somewhere. We'll get to that. And let's just see what's in libraries. Oh, just a blueprint function library and some macros. Okay, let's see what's in the blueprint library. We have just two things. Transmit name, name receiver signal pair. Oh, that was the helper just to set it all. Transmit name receiver signal. It just takes name signal transceiver, sender, pair message, and all that, and transmits it. It just, yeah, just transmits a name signal receiver, name signal, and that's it. Okay, that's not very complicated, and this is for multiple ones where it goes over them just in a loop and just sends stuff. Okay, that's simple enough. What else do we have? Macros. A get trace receiver component. Okay, just to get a component quickly. So that's that one. And transmit many. Okay, again, dealing with loops, so little helpers. Okay, so not much here. So let's look at those signals again. When we get, for example, where's the name transceiver? Name signal transceiver. Okay, what do we have here? Parent class signal transceiver base. So let's take a look at that. Open parent and editor. Okay, this is our signal transceiver base. Let's see what we have defined in the base. Just an actor component, and it has a few functions. And we have get handled signal type, which I guess we are supposed to override. Is it like access specifier public? It's pure. I guess it's supposed to be overridden. That's why it's public, right? And it just has an output, which is a name in this case. I'll get handled signal type as a name. Oh, I guess I see. Okay. Probably I used it to just detect what kind of signal that is and do a bunch of stuff. Oh, that's how I probably figure out how to make it. Whenever it finds a component that's like a transceiver, it checks if it has compatible signal type. Because you can easily make your own, okay? Didn't want to hard code anything, so I just went with little text things. And then print missing transceiver message. Oh, okay. That's another function that's here. Receiver's mess. Receiver field is empty in actor, the name of the actor. Message was sent by the get display name and get handle signal type, so I can print out what the signal type was for it. Okay, that's simple. And that's it. No macros, variables, nothing. Wow, that is basic. Very basic. Do we have anything in event graph? Nothing. Okay, so the base just tells us that we need to return the handled signal type. And that's it. So let's look at the actual implementation of the name signal transceiver. So our name signal transceiver, in event graph, there is nothing. We have event dispatcher on signal, and we can specify that event has a sender and receive data, which is a name, and just variable on signal, and that's it. Okay, so that's simple. And then we have the actual functions, right? On a transceiver, we have get handle signal type, and we implement it. We just return name, okay? The name, content of name. And then we just have functions like receive signal, okay? And wow, this is simple. Transmit signal, that's a bit more. So what is it? Receive signal. So it's just, okay, so it's just a function that can be called because it's public, right? So I guess the other transceiver can just grab it, find it, and call receive signal. And it's just being here, and it calls that little dispatcher. That's all it does. When we want to transmit signal, we just take the sender, receiver, and data transmitter. So we obtain receiving transceiver. So we get the actor that we pointed to. We find the component, the transceiver component that matches the type, I guess, of the message. Then what? Also, we get the sender. If no sender specified, get owner of this component. Okay. Just make sure there's a sender. And send data to the transceiver, which we basically, as a target, we take the transceiver that we found and we call on it, that receives signal, the one that we had here on the other component. And mark it as a success. In case of missing data, print error, like a missing transceiver message that there's no transceiver matching this one on the other actor. And that's it. Okay, that's like, wow, that is really simple. And then we have transmit signals. where we have just multiple. We just grab the loop and transmit many by calling the transmit signal, and that's it. Okay. Wow, that is simple. I just remember it took a lot of tweaking to make it right and make it look pretty and consistent everywhere, adding comments. Oof. It was a lot of work. Okay, that's that. Additionally, we have the interaction types, which initially is just set as use, and that's it. And we also have the name receiver pair, which is literally a message and target actor. And that's it. Okay, that's simple, I must say. So the core of it is real simple. Then we have the system, which has like the trace interactor that has a little bit more code, right? We have the... Where did our sidebar go? What the heck? Window. Palette. No. My blueprint? Yes, there it is. I don't know why it disappeared. So the trace interactor, the thing that traces, on begin play, it gets the transceiver component just to find it once and keep it. For the interaction signal type. And if there's none, I would just print a message that there's none. And that's it. So it just finds transceiver. And then on tick, this actually runs on tick, but it's just one thing, so no big deal. If automatic tracing, it will just do the stuff, and we have trace interval. Okay, so basically it does it on interval instead of on a stop. Okay, makes sense. And last select the actor component. Aha, so I have a little system here to detect that actually we switched from one thing to the other. So you have things like, oh, the interaction started, when it ended, and maybe less interaction, more of a, selected, like, hey, you highlighted this thing. So it won't be triggering every frame that, hey, highlighted. It's just gonna start once, and when you stop looking at it, it will send another signal that, it stopped looking. Then we have trace, which will return that it found something interactive. And I guess it saves it to selected component or last selected component. So yeah, select new actor, call on start selection. So again, it will just send those things. And when it lost selection, it will just signal about that. And that's it. Okay, so that's simple. Oh, so this will basically keep track of what actor is being pointed at the moment. And that's it. Nothing else. Okay, that's simple too. And the trace itself is a little more convoluted, where we get the sphere trace of line or line trace, yeah, which one you want. And this is trace start and location, okay. A little, offsets, whatnot. And then either sphere trace by channel or line trace by channel. Do the magic. Which hit actor, and is it interactive? Does it have the direct interaction component, because it needs to have that component to receive interactions? And is it actually enabled? Because you can just disable it. And check if it has at least one of the provided tags. So we have the tagging system and something for resetting, and save target is selected, all that stuff, and just return the result of the interaction if we found something interactive or not, and we can decide what to do with that. Great, that's simple. Yeah, set selected. Yeah, a little bit more code. Interact itself. Oh, so we can basically, we can set selected. So that's being called probably somewhere in trace. While interact is the thing that we can call. We can give it the interaction type, and okay, we can give it interaction type. Oh yeah, we can give it interaction type, and if it started or the end of the interaction, and it will just, find the selected thing and automatically transmit it to signal. So you can just call interact and that type, and that's it. So we should be able to see it in the, where is it? In the BP player character, right? The player character has the first person camera, on top of which it has the trace interactor and hot message viewer, okay? So the trace interactor, it keeps track of this, like the component, interaction signal transceiver, whatnot, whatever, it will find it on its own. You don't need to link anything here. It also has mask component and interaction signal transceiver, which will be found automatically by the trace interactor. Okay, so that's good. And in our event graph, we have the stick input, all that, mouse input, movement input, jump, and then we have the E button as the user interaction, okay? So all we have here is, if it's pressed, interact with the use type. You could add more types here. If it's released, interact with the use as interaction stop, okay? Start and stop of the interaction. And that's it. Nothing else. Absolutely nothing else to do. So I'd say this is a simple setup. You just add a bunch of components and say interact whenever you're ready, and that's it. Okay, that actually surprised me. So yeah, we've got that done. Let's just take a look maybe at something like the switch, okay? Because that receives the interaction. So open a blueprint, and what that looks like. So from components perspective, we have the interaction signal transceiver, okay? Oh yeah, for the interaction. And then we also have the name signal transceiver. So we know that it can receive and send both interaction and name signals, okay? So handle interaction signals in our set event is here. We just have the on signal for interaction signal. And base if it's start or stop. On stop of interaction, we do nothing. If it's start, we just, in case it's use, we just toggle the thing, okay? That's it. And then for name signals, we have name signal, and we just made a switch on the names. We can add a bunch of pins. So we have on, off, toggle, enable, disable, and toggle enable. So that's what I really liked about it, making it, is that we could make it so simple. You just add new thing for another name that you can receive. And there you go. You can receive that kind of thing. And you have one node that defines everything from where you can call other stuff. And therefore you have, like one central location for that specific thing that you're making, what happens if and you can just, call a bunch of stuff, set enabled, set whatever, toggle on, off and stuff. And this is just a timeline, and transmit appropriate messages after finished animation, because what I added here is that whenever you pull the lever and it stops being pulled, as in the animation ends, then it's sending its own signal to whatever you specify. Can transmit name signals, and in this case will be to activation targets and deactivation targets, okay? And you don't even need to specify what kind of message. That's the fun part. I could do, if I'll get out of here, I can just grab this guy, right? Let's just pull them here to the center. Make another one. And I can say that this guy, when in signals, what was it? We have deactivation targets. I guess that's the deactivation target. Oh, wait a moment. Oh, that's the activation target, right? That's activation target. So when you finish switching the lever, that's when it's gonna send signal. So for activation target, we can specify that it will be the message will be toggle, okay? And the toggle for the target, I can just click this thing and press this guy. And it already selected the BP switch 5. So I should have that whenever I turn it on, this guy should toggle. So let's play. We have some actors not valid there, but ignore that. I can press E on this guy. This guy switched. Press off, nothing happens because that's the deactivation. Press on, and it switches and toggles there. So, it's that simple. I just set up the, interaction between them. And if you have a bunch of simple mechanisms, like, little switches, little this, little that, throughout your world, this is it. That's all you need. A little signal here and there. So yeah, that was like real simple because there's nothing else to this component other than, most code here like this and that is just animations and something like set enabled. Okay, set enabled, literally set enabled. I just put it in a separate thing just so that the main event graph is, readable as in what's going on. Gosh, I'm liking it. I forgot how good it was. That's what I was using to try to actually make out my own game at some point. I can actually probably show you quickly how it was used. If I'll go to YouTube, let me just, because there'll be a bunch of stuff you shouldn't see. Videos, and let's scroll all the way back. So, you could probably see it well somewhere here. Yeah. So if I'll bring that over here. So yeah, I made this little thingy where you get some bunch of buttons that you can toggle other things with, right? So that was using the system. And then the other thing was that, they highlight when you hover over them. The same thing with that. It just sends an interaction that, rotated. That's it. And then with the system, you could make, for example, very easily something like here. Oh, where you just need to make a code because you can just rotate things and it's, 3 seconds to set up. And bam, done. Because you already have the whole system for highlighting things and making them work. So that was that. And of course, there were comments like, hey, why not just use interfaces and stuff? If you want to do a bunch of coding specific for all the things, I like this one. It was simple. You don't, you can always make your own. And, then I continued, made like, it into holding stuff and whatnot. But basically that's the idea. So now how can we transfer it to Nim? I think we should start with the base. Did I call it base? No, actor signal transceiver. Signal transceiver base. So what we're gonna do is, oh, this is part of this guy. Let's put him inside here. So the idea would be that we just need to create a new project. Okay, so because I don't want to just start converting the whole thing because I want the character already set up so that I can just start coding and not dealing with the whole, what do you call it? Not dealing with the whole situations that we have. This new enhanced interactions and enhanced input system, whatnot. It's just, not something I enjoy. So let's open up the new Unreal Engine and we're gonna create a new project. Okay, so interactions all shows up here. I'm not converting now. That's gonna break. So let's create a new first person like the previous one. I'm gonna go straight out of blueprints, okay? And we'll just do easy interactions. Nim, okay? Create it. Yeah, that's gonna take a moment. If we have any viewers, how are you doing? How's your night, or is it morning for you? In the meantime, I can open the folder with the older NIM projects so that we can get going quickly. So we'll have this guy here, right? Ugh, that guy launched. Microsoft Visual Studio. And this guy launched as well, but we can close it because we don't need it anymore. This guy we can close as well. So we have our easy to interactions NIM. Okay. So we can quickly set it up. I don't know how many times I did that already. Plugins. And we just have to go to the NimForUE engine. Okay. And let's clone it. Okay, I believe there's a bug that was causing some issues before fixed, so it might go quicker than we expected. So let's do git clone. Make it nice and large for you, like super extra large. Okay. Okay, that should be it. So let's go there, NimForUE engine, and do Nimble. Which version of Nim I have? Nim version. I have a good version. Okay, Nimble. New setup. Enter. Maybe it's gonna work the first try. That would be awesome. That will mean that the issue with the multiple VCC versions that I have in my tutorial for a few days ago has been fixed, and that will be awesome. I just haven't confirmed it yet. Come on. I forgot how long it takes. Still going. Oh, there we go. There's Unreal Engine. generating bindings. That means the VCC bug indeed has been fixed. So that's awesome. That makes me very happy. Okay, looks like we're nearly done. VT, virtual textures, maybe? Hmm. I truly can't believe how some people can work on engine stuff like that. Like, how do you even start working on virtual textures? Or, I know, atmosphere. It's just crazy. Can do basic vector math. Bunch of web dev. But not low level, high performance stuff like that. It's crazy. Oh, it's going. Jeez. Still going. Oh, we're done. Looks like we don't need terminal anymore. It's all here. So that means we can just go to NimFor Unreal Engine. I'm going to copy the VS Code folder so that we have the build thingy. That's it. We don't even need the game JSON anymore. I'm gonna copy it away. And when we right click, open with code, the whole folder. Then go to JSON, remove the VC toolset. Just in case, we'll have the extra module names and BP modules here for when we need to specify them. So all that is good. And VS Code, we have anything interesting? No, it's just that. Okay. Control Shift B to build. Let's see if it builds. It built. Cool. So let's launch the game. I know that there's something to start it from command line, but I don't remember. So here we go. Here, open the project. We should have the fresh project working. Oh no, our player control is in C++. Oh no. Ugh, that's not something I'm looking forward to. But maybe it will force us to do something. Maybe we'll just use the nim one or something. So we've got that, and what I can play. That works, right? Okay. And I can try to make a new blueprint from not that. New blueprint class from the class my nim actor. Okay, it's all here. Cool. Very cool. So let's do it. Let me think. So in our content, let's create a new folder. And we'll just do it easy interactions. Okay, we'll just plop it here for now. Nothing here. And we've got that open. The code is open. Yeah. So we could get to our game, not JSON, the game.nim. We could remove our anim actor. Okay, or let's just keep it. We'll rename it, right? How to make components? That's the question. Okay, let's look it up. Unreal Engine C++ component example. Okay. Add component to the actor. This is literally create new component, new object, and all that stuff. But how do you specify one? We have overall components, registration, updating, render state, physics state. Do we have an example of a component? Create blueprint components in C++. Tutorial. 2015, wow. Let's look. 4.7, yeah. Creating project, yeah. New class from actor component. Okay, I see. Write and compile C++ code, so... Do you have an example of that somewhere here? Because this is... Oh, okay. Okay, we've got some example. U class, and we can specify a bunch of stuff. Okay, and we're inheriting from U actor component. I'll call it U hover component. Okay, sure. So it'll be U class, and we'll call it U signal transceiver? Or how the hell do you spell transceiver? It's not a trivial word. Transceiver. Or transceiver. Go figure. That way. Base, it'll be off. The C++ code was where's our thingy? Here. U actor component. Okay. So it'll be U actor component. So actor component, I believe, was the component that doesn't exist on the scene itself. It just exists there attached. It doesn't have like a physical location. And what do we have here? We have that, and we have just constructor called when the game starts, initialize component, and tick component, all that stuff. We don't need those, as far as I know. Running time, whatever. And we have just a bunch of stuff. So we don't need any new props. We'll just do view functions, okay? And we can look at our other Unreal Engine project, the old one, right? This is the original signal transceiver. So get handled signal type and print missing transceiver message. Get handled signal type. Let's try to specify this, okay? But I can just right click and get me the C++ for that, because because that would be fun. Maybe there is. Let's search for it because that will help so much. Blueprint to C++ online. Sliding tool. Again, 2015. Converting. 2020. Okay. Oh, project files. Okay, so this is like a tool, right? Okay. That's not much. It's just this versus that. Okay. We'll skip that. No, thank you. We'll just do things the hard way. So, get handled signal type. That's the name of it, right? And only nothing for input, only returns a name. Okay, so you function. Now won't be calling the editor, that's for sure. Blueprint callable? That's one thing. And will be, I think that one will be the tricky one because blueprint needs to override it or something. Get handled signal type. Okay. And we just return, what is F name? Yes, there we go. No side effects. Not sure we need that here. Let's ignore that part. And we have, log hello from nim, whatever. Like, what could we do? Please override this function, and we just return a new f name. Okay. But do we need anything else? Let's go to the docs where I copied the examples. Okay. We'll refresh. View class, all that stuff. The default keyword. And then override. I think the override is not there anymore. Examples actor. Do we have the component or something? Not specifically a component, virtual function example. Blueprintable. That's for the actor, for the whole actor. So let's do. Oh, maybe not. Maybe we don't have to. Maybe you can just keep it, normal way, because I need to look into this whole override thing, because I think it has some specific things and it'll be a little bit too complex. But what we can do is specify all the interaction types, at least for now, from nim, and not even worry about that. Okay? So we'll just do that and override it somewhere else. Yeah. Okay. So the other one is print missing transceiver message. Okay. Print missing transceiver message. Print proc print missing transceiver error. Let's call it that. And it's discarded for now. I recall this U class. No, not blueprintable. Nothing like that. No. So we don't take in anything. We just get display name for the owner. what are this? Hmm. Display name and get handle signal type. Okay, so let's. Can I just put it here so I can have things side by side? That will help a little bit. Okay, so that's gonna call basically print string. And do we have some like print? UE log? I don't think so. How the hell do you print? Forgot how many questions I have here. Nothing here. We have UE warn. That's one thing. Logging. Log warn error. That's probably in the log, right? But what about printing? So we have again log, which went to log. I guess we're gonna try that UE log and then something. So let's try it. I'm gonna get rid of that, and we're just gonna UE log, and we're just gonna try first something like receiver field is empty and actor, and then we just call the name, and then we just do self get owner or something like that. I need to make it a bit smaller. Self dot get owner, I presume. Dot get display name. Okay, I would presume it's that, and then we'll add message was sent by. Okay, so period. Message was sent by. And then what we have, display name of what? Of this object, asset, nothing here. It's weird that we don't have anything here. I guess no. Display name over nothing. I don't get this part. Something seems wrong here. I'll just put 3 questions mark here. We can figure out it later. And we're just gonna add this thingy here. And self dot get handled signal type. Get handled signal type. And we'll just do this thing. And let's see how quickly it breaks when we try to compile it. Something tells me we like instant. Bam. Errors. From here, error the type mismatch. Receiver field is empty actor, this and that. So this one has F name, right? So this thingy basically would prefer all of them to be strings. So let's try to convert all of them to string. $sign here, $sign there, save, try to compile again. Did it compile? Okay. Oh, we won't be able to see it now because it's not blueprintable or something like it's not blueprint type. So if I'm gonna go here, interactions, right click, new blueprint class, Signal. Yeah, it's not here yet. So I guess I would need to do on the whole class blueprint type. Okay. And also I think on this guy here, I would need to, let's do it like this. This here will be blueprint callable. Oh, this one will be blueprint callable or blueprint native event or something like that. I don't know. Let's see what happens when I try to do that. Does it compile or it just totally breaks? It compiled, okay. Can I already create class of it or do I need to restart? Signal, not it. I think I need to restart. I think whenever we add those little descriptions, they show up only when we restart the engine. So let's close the engine and let's start new one up. Engine, but the new one, please. Oh, I could have just double clicked the new project. This one. So let's see if. Oh, hello, the drunk alcoholic. Nice to see you back. It's very nice to see you back. We're still nimming. In pain with Unreal Engine, where everything is 3 times harder. How are you doing? Long time no see, I'd say. It's actor, and let's search for signal. No, it's not here yet. Signal base. Huh. Okay, so let's see why it's not showing up. What kind of class do we have before? No, I should be able to make a class of a component, right? Yeah. That shouldn't be an issue. I'm gonna bring up maybe something here from some other project, like the previous streaming project. And let's just pop it here, the file. Because I just want to see what made the other ones tick. We just had uClass, right? Nothing on it. This one, yeah, nothing on the uClass to make it magically show out as blueprint type. I wonder if it has some defaults where we just don't need to specify anything. Or I just mess something up and it won't ever show up. That's an option too. What a bummer where things work slowly, right? Drunk Alcoholic says, yeah, I work away. So 2 weeks away and 2 weeks at home. That's so next week I can watch your streams. That's awesome. What kind of work you're doing that you're like, on and off 2 weeks? I wouldn't say it's rare, but it's not common. Again, create new blueprint class. Signal. What the hell's going on? We called it use signal transceiver base. So I'm not sure why it's not showing up. Let's make yet another class. Something like, real stupid like this, okay? We'll just call it MyNimActor2 like this, and then we're gonna do another one which will be, I wonder if it's the whole U thing. Use something bad, okay? And we'll just do UActor component. I don't see the problem in this compiling. Oh, the Drunken says that he works on a gas platform offshore. That's kind of cool and scary. It sounds like a lot of work, to be honest. Or more like real intense work. So you have probably 2 weeks where it's like, you know, real intense, and then 2 weeks where you can just relax. That's cool. Alrighty. So it's recompiled. Let's see if we have our new stuff here. Signal still isn't showing up. My nim doesn't show up. What is going on? It's like we're not. Huh. Something bad. Something bad. What is going on? Why are we getting those? I'm gonna restart once more, and if that's not gonna work properly, and we're gonna remove this guy and see if the other ones will suddenly like magically show up, because that's my current theory, but I wish it wasn't like that. Okay, Unreal, where did you go? Here. Okay, so we started. And blueprint class, and let's do signal. Not here. My nim, not here. My nim. Okay, my nim actor showed up, and signal. Wait, something bad doesn't show up. Bad. Yeah. So for some reason, our components don't want to show up. Why is that? Do we need something of this style? I'm just not sure. Let's look at the documentation once more. Because we have all that here. Do we have anything here? class group, meta, blueprint spawnable component. Do we need something of that sort? Huh. Yeah, let's try to add it. Let's see what happens. I believe it was just like that. I hope. And we can add the same thing here. Let's rebuild it, and probably we need to restart again. At least it goes fast. Okay, no compilation errors. So that's always good. And new blueprint class, signal. Nope. And something bad. Nope. Close. Start again. And there we go. So, new blueprint class. Signal, please be here. Nope. Ay. So something else needs to happen. Let's keep looking around. Documentation. Engine. Unreal Engine, C++, component, documentation. Okay. 427 documentation. We can switch to the nearly newest 5.3 only. What the hell? Oh, now from 5.3 we can switch to 5.4. Okay, good. Programming C++, blah blah blah, section directory. What do we have here? Collection system, objects, a object, handling, properties, struct. Where are the classes? Because that's what I'm interested in. The property structs, T subclass of. You name object, all this stuff. We don't care about those weird things. Object handling. I have everything but the classes. What the hell? Gameplay classes, right? And we have class specifiers here. Like, but the declaration to control how the class behaves. Abstract, advanced class display, blueprintable exposes this class to an acceptable base class for creating blueprints. So we need blueprintable. Okay, that's the first thing we need. So let's go and add it. So we'll just do blueprintable. And the same will go here. And let's see if we have anything else. Blueprint type exposes this class as a type that can be used for variables and blueprints. Yes, we would like to be able to store like a transceiver or something as a variable. That would be handy. I don't see a problem for it to be, you know, prohibited or something. This is no big deal. It's just a component. Class group name indicates that our editor actor browser should include this. So, sure, let's do that. I will do is group name will be easy. We should do easy interactions. Okay, I think that's how it's gonna work. And we paste the other one here as well. Collapse category is config, const, not really, conversion root, custom constructor, default to instanced. Depends on, deprecated, don't auto collapse, blah, 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 a bunch of stuff. Intrinsic, this indicates that the class was declared directly in C++ and has no boilerplate generated by, nope. Minimal API causes only the class's type information to be exported for use by other modules. The class can be cast to, but the functions of the class cannot be called. Okay. And now export non-transient. Okay, not blueprintable, not placeable, per object config. We don't care about placeable either. Or blueprint. This class can be created in the editor and placed into a level. Slug is propagated to a child. I guess this would be if I didn't want to force it to be made of the blueprint first or something. Transient. Object belongs to this class, will never be saved to disk. We don't care about that either. Oh, that's it. And then we have other stuff. Blueprint spawnable component. If present, the component class can be spawned by a blueprint. Sure, let it have it. Thread save, child cannot tick, blah, blah, blah. Oh, you can mark things as deprecated. That's awesome. And display name, don't use generic spawn object. Is blueprint base. States that this class is or is not an acceptable base class for creating blueprints, similar to the blueprintable. So, oh, okay. And that's it. Let's try that. Let's see what happens if we're gonna save that and run it. We've added the blueprintable and blueprint typed, and even a class group. So it should work at this point, right? I for sure hope so. Okay. I presume this won't be here yet because we need to reload the thing. Signal. Yeah, it's not here. Quick restart. Yeah, things will speed up when we already have classes existing. So let's try again. New blueprint class, signal. Yes, we have signal transceiver base. So we'll select that as a base and we'll go BP underscore test signal component. Okay. Let's open it up. We have three overridable functions. What do we have? Get handled signal type. It's a variable. Oh, that's so nice. And we don't even want to call the parent. We just want to straight up call return type, which will be Wolala. We can send Wolalas around and that should be it. This is so awesome. I don't know why, but I'm still excited when, you write something in like some esoteric language like Nim and they show up in your Unreal Engine out of all places. So that's cool. Okay, we have it working. That's step number one. We have our first thing here completed. Other than the print missing transceiver message. Let's try to do that. So can I make like a something here? Functions. Not even that. Let's delete it and let's do something fancy. We're gonna grab this cube and make it so maybe not that cube. I should be able to just locate the thing somehow. How do I locate it in the browser or whatever? In here. What is it? Content drawer. I want to locate it. Okay, that's specified in C++. Sure. Static mesh component. Okay, so I should be able to just create a new blueprint class. Oh. Wait, what was it? Static mesh component? That's it? Really? Static mesh component 0. I thought this whole thing was maybe like a component, but I guess it's not. So we can quickly make like a new blueprint class. We'll just call it an actor, BP, test actor, okay? Just something where we can shove some stuff into. Let's just add a cube. Okay, so that it looks like something. Compile, save. So that we can just grab it and plop it somewhere here that, hey, we have it here in space, okay? There it is. I can jump on it, I believe. Yep, good. So now inside of it, we should be able to add BP test signal component. Okay, it's here. It doesn't have any settings because it's not there yet. But in the event graph, on event begin play, I should be able to grab the component. And do we have something here? I don't think we have anything here. But what was it? Error, right? Print missing transceiver error. And we're just gonna do that. And I want to see where it's gonna show up. Run. There we go. Down there. So it's in the log, not somewhere else. It'll be nice to show on the screen, but okay. We're just missing that. And we should probably also do it as a warning. So yeah, let's start using like grown-ups. The output log rather than printing on the screen, right? This will be a better version when it prints nicely in a log like a proper thing. So we can just do UE warn, right? Save. And I should just go Control-Shift-B and get back to the editor in a second. Come on. Okay. and run. And now, when I go here, there it is, nice and yellow. Okay, we've got it working. The printing works. It's not full, but we'll get there. We'll get there. And we've got the, the other thing. So that's cool. So that means that we can actually try to implement some specific signal. Okay, let's pick a signal. What do we have here? I'd say let's do the name, because the name is like the most useful, where you can just, put whatever thing you want. Name. Where's name? Oh, here. It's name signal transceiver. So I'm gonna do this again, where I put this here and the code on the left. And what we can do, we can get rid of those other classes that we don't really need. And we can make new U class. It'll be uname signal transceiver. Okay, I'll use the U signal transceiver base. Again, it should be all that stuff. And then we'll just need to specify stuff on it, like the get handled signal type. Here we need to actually specify that it's a name. Why this guy showed up? Oh, because of that. There we go. So can we just copy it, and would that be it? Maybe we don't need to override anything. So just result, and we'll call it, could probably specify constant somewhere, right? U props. No. Let's just do this here. Constant name is f name. Come on, and this will be name. Okay, because it's a name signal. And we'll just shove it here. Okay. I'm just specifying here as a const, hoping that this is gonna compile it to somewhere else, but I've got no clue. Let's just see if it compiles, okay? Because I don't know if that's gonna complain about something. So far so good, okay. So we've got that. And what else do we have? Receive signal. So that will need to be public, okay. And this should be blueprint callable and everything, right? So let's do proc receive signal. So blueprint callable, but not blueprint native event, right? Because I think this whole blueprint native event made it so that we could override it in blueprints. I think, but we'll see soon enough. I might be very, very, very wrong. I just remember dealing with this whole blueprint native event when I was doing something with C++ a long time ago, because of course every time I start a project, I have some very specific things that I want to do and instantly just jump into complicated things because I'm trying to make them work like, really nicely or whatever. So receive signal, and we need to provide it with two things. An actor, which will be, I believe, a reference, although this just shows actor. The actor object type, but it's blue because of something. Actor. What the hell? Yeah, I think it'll be just this actor ref or something. Hey, actor ref. So we'll do sender, A actor PTR. Look at that. It remembers stuff. How does it know? What the hell? Then what? Received data. And that will be of type F name. Okay. And what are we doing here? We should call signal. How do we do that? Okay, that's another question. Let's see if we have enough examples of signals and such. You delegate? I don't think so. Enum. Yeah, signals. That's very interesting. How do you specify signals? It might be delegates, right? Let's search for it. Create. What's it called here? Call delegate. Okay, so it is delegate. So let's just do that. Let's just define delegate. You delegate, right? Something like this. We define the class, right? I think. On signal, so it shows up somewhere else, like even dispatcher. Yeah, and then we have on signal. Okay. Let's try to put it here. We'll just do that. You delegate F on signal, and it will take sender and receiver. Okay, sender and receiver. Bam. And that's it. It doesn't have body. So how do we call it? Let's see. New tab. Unreal Engine. C++ delegates. Declaration macro. Declare delegate. And we just have those things. How do you call them? You can bind them, but I want to execute them. Execute a delegate without checking its bindings. Executive bound is bound. So we should just have execute. Execute self.f on signal, and we just give it the sender and receiver data. Is that it? Let's see if this compiles. If this compiles, I'll be just like, wow. Of course it doesn't. There's no execute. So let's do the trick that we learned some other time. That we can go to our project. So plugins, NimForUE engine, and we have the source. We can right click and open it as another VS Code to search for things, and let's search for execute. Okay. Ooh, that's a lot here. Star. Commit execute. Proc on execute. That's abilities. I don't need that. Gameplay abilities. What the hell? Nope, that's all abilities. So that's not ill. It call materials. What about our example? We just have definitions of them here. That's when that's all when it comes to delegates. Interesting. last Unreal Engine stream we had one guy that knew a lot about Nim and Unreal Engine together, so we're able to move forward a lot. But do I just literally just call it? Maybe it's like that simple in Nim, where all we do is just, hey, run it. If that would be the case, that would be awesome. No, it doesn't know there's F on signal. Oh, I have a typo, but it shouldn't matter. F on signal. Should be lowercase too, right? Huh. I don't know. That's still the case. We might get stuck on this whole signal thing. Let's see like an example in C++. Maybe that will help out a little bit, because we kind of held on to some other stuff. We have this delegates here. So there's an usage. There's usage example. Class that defines that it has the delegate. Okay. F string delegate. Huh. Is that a function that returns F string delegate? What the heck? Oh, we take that delegate and do execute, and that's it. Huh. Where's the definition of the delegate though? This creates a delegate type called F-string delegate. For example, here's a simple delegate type. Blah, 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 one param, blah. And, and then we just define that this is, I see. So I think we need to take this out of here. We'll put it over the class and we'll call it F on signal or on name signal delegate. Okay, does it align with our docs? Delegate. Yeah. And therefore, I think we'll be just able to create a proc with that, right? So we hit the delegate, and here we can just do props, and we'll just call that we have this thing. And therefore, we could just call self on signal dot execute, I think. Let's see if that compiles. I'm going to call undeclared routine execute. Invoke, because I saw that being suggested. Nope. Just call it? I don't think so. Nope. Mismatch. This with self pointer, uname signal transceiver, sender, receiver, expected one off. Oh, I see. So we should do that has self, which will be use signal transceiver base. No. Oh, we can let's try it anyway. Attempt to redefine self. Unless we can just shove it in the class after all, because it didn't complain about it, right? There was no error. There were no errors. So maybe we can just plop it here, and it be they'll be used or something. Declared identifier. F on signal delegate. Okay, so it just doesn't see it here. It's as if it skipped it. I don't know if we're gonna solve that on our own right now. I will need to ask the creator and expand the delegate section. I'll just call self on signal and no, because again, it tries to have reference to self. Oops. Nope. Pointer U name signal transceiver. Is there? Could I specify something like? No, I can't specify self. What is it expecting here? Expected one off. Signal transceiver pointer. Huh? That returns this. An extra argument given. Oh. Do I just do on signal dot invoke or something? I think we're gonna search for delegates in a second. Yeah, it doesn't complain about us calling the on signal. It just doesn't like this. What the hell happened here? Okay, save. So let's in the other one, not this. Let's search for just U delegate or something. Let's search for delegate. UE project, and we have a bunch of stuff. Plugin generator. No. F property. New delegate base property. Okay. Try to find it as delegate. New delegate base property. Huh. Gen module. This is not easy to find here. Let's search for something like invoke. Start. Nope. Execute. All abilities. Delegate star. Is delegate. U delegate. Yeah, that's the macro, right? So we've got the macro. Saves the parameters of fields, all that stuff. Make UE mole delegate. Can I control click it and find it? Okay. Type. Huh. Just type kind. Nope. Emit U delegate. Type declaration. Type definition. Generate AST. Emitter info. I am not gonna get to that. Delegates has this whole separate nim file. Delegates. But I don't think we're gonna find anything interesting here. Platform, all that stuff. Engine. Enums. We've got Kismet that we don't care about. Branch of delegates defined, right? Hmm. Feels like it just repeats itself 7 times. Nope. And when we search for call, it'll be the same. Yeah. Can I just print it out or something to see what it is? Log? Or like, what was it? UE, warn. I'm just gonna try to print the thing out. Let's see what happens. This is not gonna work. Or is it? What? How did I compile? Maybe we'll see this thing at least defined or something. Okay, this is scary. So let's create a new group and class. We'll do name signal. Yeah, name signal transceiver. Okay. BP name signal transceiver component. Let's see what we have inside. We don't have an event dispatcher specified here. Ay. And we can do call. What do we call it? On signal. On signal. Nope. And overrideable, we have only old stuff. So no new stuff is overrideable. So I guess for that we would need the whole fancy Blueprint native event. Sorry. Can we call something like receive signal? Receive signal. Okay. We can call that. Sender will be self. Owner. Get owner. That will be the actor. Okay. And receive data will be go away. Okay. Compile, save. And that should start on the event begin play. So let's get our word cube again. We received it. We'll delete a test signal component. We're gonna add the name signal BP name signal transceiver. Okay, got this guy. So doesn't compile because we don't have that. We should have that, but let's try that. And output log. Warning, and it prints out nothing. Okay, I officially give up. I'll need to reach out to the NimForUE engine creator and ask how to deal with delegates, and maybe, you know, write down documentation about that so that we know for the next time, because yeah, I don't know how to bite it, where to start. So we still have half an hour, maybe an hour. I'm not that tired, so I'm gonna close up this guy. Sure, save it. Let's go the other, close the other online engine. Don't save it, we didn't do anything good in there. And you go away as well. I'm just gonna switch to a different project that I was kind of tinkering with today. Where is it? Random nim. There we go. This here thingy, which is a bunch of code. This is a little project that I started. It's relatively simple. Basically, the whole premise here is that we have a number of people. Let's say here, we'll call them agents. Each has a name and weeks that they don't want to, whatever, work or something. And this guy, for example, or she, Anne, doesn't want to work on a week number 1 and week number 3. So we have those people, and we also have the, like period of how many weeks we want to schedule. In this case, it's 5. And each agent needs to be scheduled for exactly 2 weeks. No more, no less. In that period of 5 weeks. And then we've got, additionally, previous week agents, which is like, the prior to the time that we want to schedule, what was the last week? That was what the schedule was. So the whole idea is that we have the numbers of those weeks, and we need to have at least 2 people assigned to each. For each person, they can be only during 2 weeks, and additionally, each person cannot be assigned to 2 consecutive weekends. They need to be assigned only to they need to be staggered at least. So I wrote code that, we have a concept of agent, which is just named and excluded weeks. Agent state, which I just started changing because so far I had a code that just had the whole agent object, but now I'm trying to make things leaner, and I want to just an ID in a sequence for the agent, and integer set of integers that which weeks were selected for the specific agent. And then we have the whole plan, which is basically a number of states. So basically, state is like each agent state. So let's say there's 11 agents, there will be 11 states that hold, for which they're selected and for which they're excluded. And then also we have like locked states is basically as it generates possible solutions, because the way I'm doing right now is just, hey, try all the possible solutions as long as they don't sound outrageous. And this basically increases just not to keep remaking like previously defined all previously defined possible solutions. So right now I'm in the process of optimizing because I have the working. So for this, I can show it to you right now because I need to change all those agents and integers. So I need to deal with a bunch of errors. So for agent state, I would like to do something because I have agents up here, and all the week counts and everything is up here as well. So I would like to make a little proc. For agent state, it'll be get agent. And we'll just do ID, okay. It'll be integer. Or no, this will be on the agent state, okay? And we return the agent, and this way we basically have returns agent for given agent state. So we will be able to go to return agents, and we just do state.agent, and that's it for now. Okay, I'm doing simply. It's simply because we have this table from which we can just pull, and I just don't want to store the whole agent inside the agent state because it's copied hundreds of thousands, millions of times, and it just eats RAM. Like within 2 minutes, it ate nearly 80 gigabytes of RAM. I need to stop it because it will just eat all the RAM. Okay, so we've got that one. What other errors do we have? Because we have the get agent, okay. So we could use that one. So is empty. Week ID not in state.agent excluded weeks. So let's do exclude, like, let excluded weeks is get agent. I mean state get agent excluded weeks. Okay, and that should be a fix for now. Next one. What do we have here? Which one? I better start hiding the other ones because there's just so much code. For some reason, I'm getting weird highlighting for whenever I try to separate things. And not here. Not here either. Here. Resolve.agent. Okay, set up agent state. Oh, okay, I see. So we just provide the agent. We are not going to do that. We are going to do agent ID, which will be the integer. And we'll just pop it here. Okay, and we'll get to that a little bit lower in the code. And where else do we have errors? Here. The agent name. Agent state by agent name. So we have the plan. So for each state, the name will be basically... Oh, we're setting it? Get state by agent. If state agent name is the agent name. Okay, I see. State.get agent dot name is this. Okay, that works. Shouldn't be too bad for performance, right? Existing state dot agent name equals to this. So get agent dot name. These are easy fixes. This is all good. This is all good. And this is all good. Set up agent state. And we'll give it the agent. We don't do that. That's it. Set up plan. So instead of just going through agent and agents, I don't even use that agent itself anymore. So I could do from 0 to agents.length or len, right? Well, let's just not go all the way up there. Agent ID, which will be here. Okay, that one's fixed. And just a few more. Here, so get week schedule. Okay, so we're just assigning names. So we'll just do get agent and dot name. Okay, not here. Okay. And here is, yeah. For week, for all that. So we have state. Let agent name is spam. And we just plop it here. There we go. That looks good. And we have the other presenters table, which needs the same, but only once. Get agent name, and we don't want that. So that's gonna go fast. And we can collapse this guy on this guy. Let's scroll down somewhere here. This is good. Get status. It needs the excluded weeks. So to get agent dot excluded weeks. Okay. And here is all good. So let's scroll down. We have a little bit more here where we get the agent name. Yeah, we're not writing anything else. Get agent name. And we have a little bit at the end. Conflicting plans in progress. What the heck? Where do we use agent? And then we're here. Sequence plan and form plan. Oh, plans in progress. Don't finalize those. Don't finalize those. Okay. What? There we go. And here we have name and state to variate goes all the way up to here. Wow. So just gonna do here. Wait, that's in 4. So I might as well just do it here. Let agent is state to variate agent. Get agent, and we're just gonna do it here. Name. Okay, is that everything? Can I run it? Run a release mode so it goes fast. Okay, we have the conflict. And it should go every 1 million iterations. Oh. Why did it print something already? It just prints it every iteration? I guess so. Okay. So focus 18. Whoa, okay, let's look at the RAM usage because this is gonna be painful. Or maybe not. Oh, it already finished. Okay. It went through how many iterations? I think 300,000. Wait, 3 million operations, and that's it. Found 1,044,541 conflicting solutions. That was fast. I just want to run it again and look at the RAM usage and memory. 36, 37. Huh. Yeah, I'm like brute forcing the whole thing. Okay, 47 gigabytes down to 30, so 17 gigabytes. That's how much RAM it used to just store all this. But that's better because it was storing how many? 3 million separate possible plans. Because that's how many it got. Okay. And now let's do it where I will remove the conflict because there's one thing here where we have those agents set. This Oscar guy, it says that on week 4 and 5, it's not available. So let's say that we have weeks. Let's just do a nice little comment. So we have weeks 1, 2, 3, 4, 5. Okay. And we also have the 0, which is like the previous week. So what we can do here is that in a 0 week, we can see that Oscar was scheduled. So where's the little check mark? Where'd I go? Never mind. Let's say that O is that was scheduled, right? So we also know that on 4 is X and 5 is X because they shouldn't be scheduled there, right? So we have week 1, 2, and 3 to schedule them. And they need to be scheduled on 2 weeks out of the available ones. But the problem is that if we're gonna schedule him on week 3, that's okay. That means that he can't be on week 2 because it's adjacent to this one. So we need to stagger them, and therefore we go to this week. But that means that it's colliding with this one because there are 2 consecutive ones. Therefore, no matter how we're gonna arrange them, there will be a conflict. That's why when we started the whole thing, when I'll start it again, run, it shows following have unavoidable conflicts, Oscar. I have like a little check where it just runs through. It takes each agent and their initial state that basically is where they can't work and all the weeks, including this, and just generates all the possible combinations and checks if there are no like valid combinations. It's just gonna say, hey, there's a conflict. So that's that. So if we're gonna remove like a week 5, for example, out of Oscar, we're gonna run it. It should look a little bit different. Where's my task manager? Because there's no warning about it anymore. We're just going over everything. And performance, memory. 31. It should be way more possibilities now because we just added one extra possibility that's open. That question mark here. Oh, I just need to fix that, huh? Yeah, add new line. But this is Oscar here, and it just tries different things. It just prints every 1,000,000th iteration. So that's that. It's kind of fun. I like that little visualization. But you can see that we're already at 6 million iterations, 7 million iterations. But it's not too bad. It found, I mean, in progress, it has scheduled 29 plans and it prioritizes those, and then eventually we'll get to the conflicting ones because it prefers to search through all the possible ones first. I think I have it set like that. Or I might be, I don't know, I need to check that. And it just has total how many, whatever. But valid, it already found 9,552 valid ones and no conflicting ones because it's just not going through them yet. So I think this will, I don't know when it's gonna finish after how many iterations. While this is running, I'm gonna, and for now it's just one process, so it's not very optimized. So let's check if this whole, if it's gonna process the conflicting ones, because I had it set somewhere here. It's gonna be a little bit convoluted code, so brace yourselves. So we get to forming the plan. We specify, you know, the list of valid plans, list of conflicting plans, plans that are being in progress currently, and we start with the first plan, like the initial start, and conflicting plans in progress. So the conflicting ones are just being shoved off to a separate list. So we're going through all the valid ones first to find a valid one, because if we have a valid, at least one valid solution, we can just scrap all the conflicting ones because we don't want to find those anymore, and that's it. So a little bit of stats, thing to just print the status here that we're seeing. And then check for unavoidable conflicts. So it just goes through everything and, you know, for each, gets combinations for each state, for each agent and whatever. And then we generate and check all possible plans. So we just count iterations, and while any plans are in progress, and this is already wrong because there are, so if any plans in progress and we do, yeah, let's just have it the way it is right now. We don't want that. So basically it takes the last plan that was scheduled in a plans in progress. And this is just printing out this thing every 1 million iterations. And then we check plan validity first. So we take that plan, we call get status. There's just a bunch of code that is basically checking, you know, all those states and weeks and whatnot, and we'll return status like invalid, which means that, you know, this plan won't work out. So we just, all we do here is discard it, and we just increase the stat invalid plans count. That's it, and we just continue to the next iteration. For valid with conflicts, what we're doing now is that if there are any valid plans, if there are no valid plans, if there are equal 0, then we're gonna add this plan to the conflicted ones. Okay. Okay, so this is like a finished plan. Okay, so this is a finished plan that we can just map as, you know, this finalize just strips out some data, so we hold even less. And then if it's fully valid, we add it to valid plans. Okay. And if it's incomplete, we just continue further, where we can go over each incomplete state and generate all possible plans. So what we're doing here is basically we check if we're at the end of the roads yet. If not, we just skip. This is just so as we're generating from left to right possibilities. We don't go over that. Then we have state to variate. So we basically copy the plan states. Oh yeah, we get the, like, you know, because plans first plan that's gonna get generated will be like some combination here, and then when that one is being processed, it goes more. So this basically picks which agent to start generating variations of. And then state to variate agent, we just, you know, extract the agent, that's agent data about it. And then we get status. So if it's marked as incomplete already, and here to start with, that's good. We can just generate it. Okay. In this case, we'll do state to variate is incomplete. Okay, it's a new plan. Yeah, copy the plan, advance the locked state. Okay, and plans in progress, add the current plan. What does it do? Incomplete. Oh, if it's not incomplete. Oh, I'm misreading things today. If it's not incomplete, as in it's conflicting or maybe invalid or something, then we just postpone the whole plan to just recheck a few things and whatnot. I don't know. For some reason. I don't remember why I added that. And then generate all possible combinations of week for that. So we basically, take that state and calculate all the possible combinations. What is happening here is that I'm taking, like, you know, all the question marks, which is empty spots, and generating all possible combinations, how to populate them, that are only too long. Two spots long. That's why you can see that in each column here, you have exactly 2 green boxes tested, because there's no point of testing anything else. With more is an error, with less is an error. So just have combinations of length 2, and I have some other stuff that generates that. I'm randomizing them so that we're not stuck in everything one row. It just jumps around a little bit. I guess it makes it more highly likely that it's gonna find something. We have already 27,000 valid combinations, and RAM is still low. Okay, good. So then for each combination that we generated for that specific agent and that specific plan, we basically, what are we doing? If there are no valid plans and these two boxes are adjacent to each other, we already know that this is going to be a conflicting one. Therefore, just add this plan to conflicting and move on, okay? But if it's not conflicting, you know, we copy the plan, we advance the locked state, and for each empty week, as in each combination represents an empty week. I mean, each combination has those two empty weeks, right? Like this one and this one. So for each one of them, and we basically highlight this week as selected, okay? So for each two boxes, we just select them and add that as a new plan somewhere. So to the list, so we can see that in progress is 39 of them, or it's going to update to 29. It just jumps around like that, adds them in progress. So in the next iteration, we're going to check if it's valid or if it's not valid, all those things. And that's it. That's how we do it. That's how it just figures it out. So I was thinking that maybe we could pre-calculate those possible states. And yeah, I think we could. Because as we're progressing from the left to the right, no matter what we choose here, it shouldn't affect those here. We always have the same combination because the whatever's disallowed stays in the same spot. So right now, for each iteration, every time we select something, we need to basically recalculate the combinations, which is this whole thing. Calculate combinations, length of 2, for example, and we basically go over that, generate, and we have this whole recursive thing. So this is a lot of stuff happening. So I believe what we could do is basically say that, hey, our agent object could, because we don't want it in state. States are, the state is saved inside the plan, and as you can see, we have saved we have 22 in progress ones and 15,346 conflicting plans in progress. For each plan, we have at this point 11 instances of agent state, which is, a lot. If we're gonna add those combinations being pre-calculated there and copy that many times, no thank you. I actually start to worry about RAM in this context, which is crazy. I mean, it's running so much better than it was now that I actually removed the agent, so we're not copying the name 30 million times. So yeah, that's good. Oh, we already went to 102 million combinations tried. Go figure. That's a lot of combinations. So on top of that, we'll do weak combinations. Should be a sequence of integers. Okay. We're just gonna have it here. And where do we create the agent? We created somewhere, right? Count selected weeks, set up agent state. That's the state. State by agent, all that. I guess we can pre-calculate somewhere here already, right? Or no. Let's do it somewhere here. Where are we doing that? So we have forming plan, okay. And here we set up the plan. When we call setup plan, this is where we basically go for each state, we set up agent state, okay. So here we have all the possible weeks. So what I could do is Yeah, well, let's go to setup agent state. Let's see. Result.agent is agent ID. Okay. And select the week. And I would also add it here where we just do those combinations. The selected weeks are empty here, so no thank you. We will need to go here, states, add state, apply week from names. That's in our setup plan. And that's our, okay, apply week from names. The 0 week. Oh, because excluded stuff is from there. Okay, and here we could do probably, no, we need to for each state. Ugh. For, state in result states. Okay, for each state, we're just gonna do state dot populate weak combinations. Okay. Well, like let's do generate weak combinations, and on top of that, we have the state which has the ID and everything, and already all the states. So that's all we should need. So agent state. Let's make that proc here. Whoops, not like this. Okay. Check with combinations for a given agent state. Let's do regenerates. Okay. And I have calculate combinations that takes the state. No. I have calculate combinations that takes the state. And returns that. Oh, because this doesn't exist here. Okay. So, var agent is state get the agent. Okay. Agent. With combinations is this, and then we can do basically state.set agent, and we just specified here. So let's just add the set agent thing that doesn't exist, and this should be it, I guess. Wow, that's actually simple. Set agent. So we go to the agent. Where's agent? Get agent. Set agent. Okay, so we'll just do agents equals the agent. So what's the problem here? Agents cannot be assigned to. I see. Well, now we can. Okay. Okay. Type mismatch here. Really, what doesn't like it? State, set agent, and we provide the agent. State. Oh, because the state needs to be a bar here. Or does it? It shouldn't be. Set agent. This doesn't need to be bar. There we go. Okay. That's better. Bum 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 bum. If that's the case. We just need to hook it up so that it's not using the calc combinations anymore. Let's find all the instances of it. The combinations is state calc combinations. So we do state. Do we get the actor somewhere here? We get it here. So we could just do let actor is this. Okay. And we can just do actor name. And here we'll have actor dot weak combinations. Okay. That's good. Do we reuse it like many places? No. We just have it here. Bam. One line less. I mean, not really, but we're... Oh, no. We're doing combinations once more here. Oh, no. For combination... For singular one. Okay, so that's good. Where's another one? Where is it? This whole code. Still going. 169 million combinations. Oof. Why so many? Something broke or something? This is confusing. It shouldn't go that high. Go figure. Calc combinations. Where else do we have it used? Here, state to variate. Calculate combinations. So weak combinations. Yeah. State to variate. And we have the agent, so we just get the agent dot weak combinations. And this is used. Oh yeah, we want the copy because we shuffled here. Okay. That makes sense. Good. Already so much reusing. And we get back to it. Calc combinations. No more uses. Okay, that's good. Calc combinations. Only 3. 1, 2, 3. Okay, that's absolutely awesome. So let's stop this. And let's see if anything will go a little bit faster. I doubt so, but maybe a little bit. If we repeat it millions upon millions of times, might go a little bit faster. On the other hand, we're doing lots of copying, but with generating them, we're doing even more copying, so who knows? I mean, right now it's extra slow. What the hell's going on? Did we just make it like 10 times slower? Seriously? By having them cached? What the hell? This is confusing. Generate weak combination is in a setup plan that's called once. Okay, this is not the expected result. What just happened? Did I generate them some wrong way? Because for each agent, we have them pre-generated. I never have like modification of that. So we're reusing them and just rerunning them as we plan forward. Okay, this is totally unexpected result. Unless I run it in debug mode right now. Stop. I run it. Release mode. Nope. It's again that slow. I should have versioned that because I don't know what's going on here. Let's just start undoing things. State avert, call combinations. Uh, Set agent, all that can stay, right? So I guess I already undid the whole thing. So we stop it. Jeez, it's so slow. What the hell's going on? And let's start again with those changes undone. And what is going on now? Because it's still going slow. Unless copying those sequences for those combinations is like extra slow or something? Yeah, the same thing. What the hell's going on? Where am I losing so much time? What if instead of having this inside the agent themselves, I just have a separate thing for weak combinations, okay? So we're gonna do agents will be let, and we'll have var weak combinations. Okay, and we just need to do for agent and agents. Agent, I mean, just weak combinations. Add. Just add empty thing, okay? For now. Just so we have it all pre-done. I think there's a fill or something, but I don't feel like looking through the documentation right now. So we can remove, yeah, we remove the whole thing from here. So when we go down here, set agent. We don't want set agent anymore. Okay. Generate weak combinations. So for each agent, and we do just weak shoot combinations state dot agent. Yep, is calculate them, and that's it. Why isn't state happy now? Type mismatch. Sequence of this to. Oh, because we have sequence of sequences of sequences. Yeah, so this is a combination. This is a list of combinations. So we need to have a sequence of those. Okay. Oh, this is really horrible looking. So we updated that, and we are not using it anywhere yet, so no big deal. Let's just run it. And let's see if it's back to speed. What the hell did I change that slowed it down so much? Okay, a little bit faster now, just a little bit. Okay, I guess that was it. Just copying it so many millions times. Every time we need an actor throughout the process. Gosh, that tells me that we... Actor name, we need it, and excluded weeks, we need it as well. But we need them in very separate scenarios. So again, I feel like what could be done here, just separate them. So we can access the specific thing rather than extracting the whole big thing. Hmm. Hmm. What if? Hmm. Let's have it the way we have it now, okay? Let's just modify the checking for, getting the thing again. So we don't need that. Set a plan. Yeah, that's good. The count selected weeks. No, count combinations. Okay, we have this instance, that instance, right? Generate weak combinations, yeah. Then we have here, state combinations. So I would need to do state dot get. Oh no. Weak combinations. And we just get the idea of the agent, okay? Let's keep it like that for now. It's ugly, I know, but whatever. Or we could do here. Proc get weak combinations, and we'll just specify agent ID integer, and we return the thing for a specific agent. Okay, so not that long thing. For a given agent, and this is where we can put that thing. Okay. This would be agent ID, and we can specify the whole thing like inline, right? I should probably use it more all around. So that's good. Other than this is not good. Wow, pragma inline. What? Oh, because it needs to be here or something? How is inline wrong pragma? What the hell? Documentation, come to me. Inline. Oof. That's not very helpful. Let's go to. Nope. nimlog.org/docs. It's just annoying that there's no link to this page from anywhere there. Inlining, I don't think that was here. Inline to inline iterator, that's just iterators. Part 2. Inline. Yeah, it's just used here. What the hell? Why is. What? Oh, there's no error now. Okay. I guess it recompiled stuff. What a silly tooling. Sure, we have one more here, so we're just gonna do state to variate, yeah. get weak combinations, state to variate agent ID. Not this. Because here we have this whole copy state to variate agent. And we have to use only one spot. So instead of copying the whole thing, maybe I would do something like this, hoping that this would be optimized in some way. So maybe get agent should also be marked as inline. Okay. Yeah. So we've got those. Let just me search for weak combinations because I think we still have it somewhere wrong. Not really, I think. Oh, there it is. See? Get weak combinations. Let's try it now. Let's see if we have to speed up or again slow down. Oh, infected mushroom music is good for programming at night. I have no idea if we sped anything up. Where was the whole thing with the state to variable agent? We can remove that one. Let's stop and run again. Okay, it's not slow. Okay, it's doing something. I don't know, it's slowing down, making it faster. All I know is we're reusing the combinations. So that's that, and yeah. I wonder if I would replace those sequences here with. Yes, let's try to do that. One crazy thing. So let's add a new type. Okay, and we'll call it weak combination. And that will be a array. And this will be weeks per agent. Let's sure weeks per agent integer. But the thing is that weeks per agent is not compile time. Yeah. And I would like to keep this code as in I can configure it. So yeah, let's scrap that idea. We can't do it really. Okay, good enough. Sequences work. Do I have any other optimization in mind? Let's just try a different plan because I want to see something a little bit more close to life. Word. Okay, so let's copy all this, and I'm gonna just comment it out for now. And let's say that agents will have 1, 2, 3, 4, 5, 6, 7, 8 agents maybe. Okay. Let's save it like that. And the previous week maybe we're just gonna remove. I mean, this guy doesn't exist. This guy doesn't exist. Let's add that there was one other. I don't know. Sure. Harry. Okay. Well, let's run it with that, because that should go way faster. Oh, it finished? Okay, that was a little bit faster. Okay, Drunk Alcoholic says, I am smashing head against the keyboard trying to make an online API work in Nim to control my air conditioner I have out and shed. Very frustrating. Can I help out somehow? I haven't done an API work in Nim, so I don't know if I can help, but if you need help, I'll be happy to help out. Okay, so for 8 actors, it took only this little to find. It was 213 valid combinations. So that's very awesome. All right. Okay. This is nice. I approve of my solution right now. I mean, it's a mess, but it kind of works. What if I'm gonna make one of those invalid? I want to see if I'm processing those conflicting ones or not. So let's say that we have Harry, and we have 5 weeks right now, okay? So we have 0. We have 0, and then we have 1, 2, 3, 4, 5. Okay. And Harry on week here, it's like that. And then we have 3, and we have 4. So 1 can be here, and then 1 can be here. So what if I'm gonna also exclude week like this? It will have possibility of going with 1 and 5, but the 1 will be unhappy about this. So let's add week 2 to it. He's on a 3-week vacation. And when I run it, we instantly have that there's an unavoidable conflict. And it just found only 3,861 of those. I don't think that is correct, because there were 223,000 of them here. So let's make sure that we actually are executing those conflicting ones whenever necessary. Plan validity, and we had this thing here, generate all possible things, and blah blah blah. For combination, so if there are combinations like this, conflicting plans in progress, bam. Continue, new plan, blah, blah, blah. So it's adding those to the conflicting plans in progress. So we have that scheduled. We just as we're processing things, where's our main iteration? Here. Next plan is plans in progress pop. So we would need to add an if expression here. If plans in progress dot length is larger than 0, we do this. Else conflicting plans in progress pop. Okay, we're gonna do this, and therefore while plans in progress plus conflicting plans in progress. That should work. So let's try that. Okay. Now we're talking. We're generating all those conflicting ones and going through both non-conflicting and conflicting ones. Yeah, I mean, from that point, there will be only conflicting ones. Yeah. But in progress are showing 4. Interesting. Huh. The Drunk Alcoholic says, thanks for the offer. I don't want to interrupt you on your current projects and stream. Maybe when you have time, I'll post what I have and GitHub for you to take a look. Sure. I know if you can message me on YouTube. You can probably find me as xconti on Nim, Discord, whatever works for you. Yeah, I'll be finishing the stream probably in 10 minutes, so I wouldn't have much time to help out. Alrighty, so this is, wow, going a lot longer to find those conflicting ones. Already found like a lot of them. Okay, so that's that. We know there are no valid ones, so we'll be going through all the conflicting ones, which kind of sucks. But we can live with that. So the next thing would be... The next thing would be to do scoring. Drunken says, cheers, mate. I can't do Australian accent, unfortunately. But I'll imagine that you're saying that with an accent of... what was his name? From The Boys. From the TV series. The Butcher from The Boys. Oh, the new season is coming out on 13th, so I am waiting. It's such a good TV show. Okay, so this is somewhat working. We're getting a lot of conflicting that we actually have in progress. What's the RAM usage then? Because we're finally getting to millions. Huh. Okay. It uses 35 gigabytes of RAM for now. So, ouch. Yeah, and memory usage 62. Okay. Keeps growing. So that's the problem. If we have encountered that situation, we should probably stop at some number of figured out combinations. Just pick some of those. Yeah, 42 gigabytes. I'm gonna get to 50 and I'm gonna stop. Enter exe. There's no like high priority mode. Nope. Come on, finish. I don't think it's gonna finish. I already went through 52 million combinations. And the conflicting plans available, 12 million. Jeez. Okay, let's stop it, because 50 gigs is a lot of RAM. Maybe I'll just set them all to drive, to SSD, and just fill out like 2 terabytes of of pointless plans. Oof. Okay, that works. So let's say that let's say that if I'm gonna get to like a number of 1 million conflicting plans or something, I'm gonna stop. Or like not even 1 million, 50,000. So basically, let's make it that I would be printing out. Let's do it like here, the validation of iteration, and let's do here something like every, I know, 25,000 iterations. Okay, we're just gonna do if conflicting plans, the length is larger than 50,000. Break. Okay, this is where we're just gonna stop and excuse me. And we're just gonna break. And after the loop, what we should do is make sure that plans in progress is empty and conflicting plans in progress is empty, so that we have everything clean. All right. And so be clean up. We print the stats. And then I would like to basically what we can also do is if valid plans there are anything conflicting plans, just wipe all the conflicting plans. Okay, because if we have valid ones, we don't care about conflicting ones. So what we could do here is what we could do here would be to start kind of assigning points to them, because we have basically all those plans, they are of type form plan. So it basically states which is which weeks are selected. Okay, and we could, based on that also calculate if it's a conflicting plan, if it's a valid plan, all that. I mean, we already have that specified, so I guess we don't care. But I would like to be able to kind of do something nice about them. So let's see. I have plan stuff here. So here I would like to add something like proc score, and we do plan, which would be finalized. Formed plan. Okay, and I want to give it a score. Let's say it will be an integer. So returns our score for plan. The score. I mean the higher the score, the better the plan. I don't know that yet. But the idea would be that what affects the score would be variation of number of agents assigned to a week. Okay. So that will be, I think that's the main thing, because I would like the weeks that are assigned to, like, to choose the plan that has the nicest, like the most even thing. And then we would also have score valid. So we'll have a separate score for valid things and separate score for whatever. So score of the plan. The lower the score, the better the plan. Okay, let's do it that way, because here we care only about variation. So we can say that each like order of variation increases this and that. So we will need to basically calculate how many there are per week. How can I get a week for the thing? Get week combination. I should have something like that, right? Get week schedule. Okay, and it's a sequence of strings. Okay, sure. So let's do for let weeks, okay, is plan dot where is it? Get week schedule. And that's for a normal plan. Can I make one inherit from the other? Because this just adds locked state. What if I'm gonna do something like form plan is object of form plan. So we extend it, right? The non-final objects. Must be root object. Oh, seriously. Shoot. So formed plan ref. Oh, but that will be suddenly a ref object. Yeah. Oh, root object. Oh. Duh. Okay. Of root object. Ah, form plan. That's better. And we don't need to redefine states. We have all that. Okay. Maybe nothing broke. Hopefully. So now let weeks is of plan. Okay. So for the get week schedule, we don't need anything special here. It will be a form plan. Okay. And that still works. Okay, so I can just do plan dot get week schedule. Yeah, for each week. Var weeks. Will be sequence of a sequence of string. Okay, and then we're doing basically for week in. Yeah, from 1 to weeks count. And then we just add them, okay? So we've got that. We've got all the weeks. Now we could basically start scoring, right? So we would need to calculate the overall what's the name of it? Something with D. Deviation, right? I don't know what standard deviations are or whatever. I'm not good with with the whole thing, but the overall maximum, okay? So for minimum agents per week is, will that work with this whole map iterator where we take the item map item, so item.length, and we just call minimum all of it. That should work. And max. And let's do var overall deviation. We just do that. And result increase by overall deviation times 100. Okay, we'll just say that every point of deviation adds 100. But that's that. Now, how can we make it also? So we'll just do it like overall deviation and some kind of variance from within a week. I mean, maybe from average deviation from the average. So average agents per week. What? All those. Do we have like average or something? There must be some. I think there was maybe in math or something. Language manual. Not manual. Jeez, standard library. Core algorithms. Collections. I don't think this will be in sequence utils. Doesn't even show up here, sequence utils. That would be more like in math, right? Average or whatever. String time, generic, math. Statistical analysis, look at that. Regress and stuff. I don't think we can calculate anything here. What the hell's mean? The mean of something. I don't know those words in English too much. What is mean in statistics? Measure of a central tendency that represents average value of a set of number. Values in the data set and then divided by the sum. All the values, the number of values. So that's just like, yeah, the average. Okay. Okay, perfect. That's what we need. So, where was it? Here. Mean on an open array of floats. Shoot. Oh no, it just returns a float. Okay. So yeah, let's do standard. What is it? Standard stats. Stats. Okay. And we'll just do mean. Okay. Okay, that's better. It should be a float. Yes. So we'll do times average. Well, let's do times 50. It'll be a little less important. And what we're gonna do here is dot int. Okay. So we have average agents per week. Sure. We'll just do result. Oh, that's average agents per week. Okay. So we'll just do that. Okay. And we'll follow the 50. We'll just because we need to go over each agent, right? For week in all the weeks, deviation is weeks length minus this thing. Okay. Float. And we'll just do this deviation times per week. So let's do 50 by weeks count. Okay. Let's just use, yeah, normal division, right? We can't. uh, da, 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 dot end. Will that work? No, it won't. It's still showing wrong one. Okay, now I guess it takes some time to recalculate. Wow. Okay. So we calculated this and that. So let's just say that this is enough for our scoring for now. Just to even it out. So let's do it now a little bit differently. So we have the score the valid ones, right? So what I could do probably is, I mean, in theory, we could just score every single one, right? Yeah, let's do it for now. So we have the thing where we did that. Now will be scoring time. Okay. So let's say that we just store all the scores as the thing. So now for each plan, we just score the thing. Let's actually do it where we no. I just add the thing to the thing again. Uh, the form plan. We have plan like here. So let's say scored plan is object of formed plan. We just add a score, okay? We'll just do that. So we'll be copying a lot of them, but we might as well just pop things off, right? So let's do while valid plan's length is larger than 0. I'm just gonna pop the plan. And instead of doing this, we're just gonna have scored plans sequence of scored plan. Okay, that should work. So now we have that, and we do new scored plan of the states and the score valid. Perfect. So we're gonna score only valid points for now. And then the whole idea would be to find few most scored and find few least scored and just print them out for now. You know, something to start with. So let's do get 5 best scored plans. Oh, we're doing sorting. Oof. A sort in place. Let's not do sorting. Or should we? Okay, all right. Sort. I need to learn it at some point, I guess. And sort from tables. Algorithm sort. Where's that sort? Okay, default nim sort, an implementation of merge sort. The sorting is guaranteed to be stable, that is, equal elements stay in the same order, and the worst case is guaranteed to be blah blah blah. So we basically provide, okay, so it's in place. We provided an array, or whatever, a list, and we have proc that compares. And an order ascending or descending. Okay. All right. That's doable. People of sort do. Oh, you can inline ad hoc comparison procs with the do notation. Mm-hmm. Okay. And the other one is shortcut version of sort that uses system comp as the comparison function. Oh, that will be better. Or not really. We need to do this thing. So, blah, blah, blah. Sure. Let's copy this. We're gonna do, sort by score. Yeah, we wouldn't even need to save scores if we just sorted it, and then we just don't care. But we're storing the scores for now, so why not? And we remove the list of initial plans. So one will be decreasing in length, one will be growing, and at the end we could remove one and the other. Whatever. Sort by score. So we do. Oh. Oh, okay. What was an example of do? There it is. That's better. Let's do this. So we'll just do valid plans dot sort, and then we do the do xy person. Not really. Have scored plan. Okay. Compare x dot score and y dot score. Okay. And then just ay, ay, ay. We don't have anything else to compare by. Um, I guess we'll just do x dot present. Okay. This is the present. And what the hell was present thing? Plan has locked states. I'm not using that, so the present thing can be with the formed plan. Okay. I'll just do that. Oh, that was don't use present of strings. That was some little thing. Do not use comp string here as we want to use the specialized overload. Yeah, I could just do sort of those two values, right? Or maybe it's fine. Whatever. CMP. Yeah, that's what it's supposed to be. Present and Y present. Present. Not efficient, but I don't care at that point. It's just only several thousand iterations. So now we just need the arrows. What the hell was arrows? Sugar, right? Sugar. Tap this match. Oh, not valid plans. That we scored plans. Yeah, it's gonna update in a few hours probably. So let's do print top 10 from here to here. Okay. So let's do plan number this. Bam, bam. Okay. And I'll instead of present, we present as table. And yeah. So that's table formed. There we go. So that's that. And then will be echo bottom 10 for I in proof. Can I do like -11 to -1? And that's it. Um, doesn't like the backwards index? Why not? We have n. So what? This is strange. Tab mismatch first. Special variable result is shut out. We don't care about that. To 12. Tab mismatch. Get state by agent plan name. 212. Ooh. 212. Hiding somewhere here. Oh, get state by agent. Floor plan. There we go. And now where's the another? $481. Tab mismatch. Sort scored plans do this and that. And expected one of order table, sort order ascending, blah blah blah. I should be able to just do this, right? Proc xy returns an integer. That's huh. Let's get the other example of the sorting. Where do I have sorting? Sort, 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 sort. Let's just try that. Getting pissed off that that's sorting. Sorting is always like overcomplicated for some reason. Compare CMP scored plan. Scored plan. Okay. It's integer. And just do this. XY, blah, blah, blah. And then we just do scored plans. Oh, that's probably just needs to be var and that's it, right? Again, I'm stupid. Forgetting about these basic stuff. CMP scored plan. So, I don't know, scored plans is var. Type method expression scored plans and this scored plans. A sequence of scored plan compares this, that. Expected one of the first match. Proc sort A, B, where order table A, B. Blah, blah. Scored plan, comma, scored plan. What the hell? Sending or whatever. This is getting me pissed off. I'm starting to genuinely hate sorting in them. One big no. Why is that? What is it complaining about? I don't understand that part. So we'll just remove that. Back to what it's supposed to be, right? Score plan, sequence of score plan and proc. X and Y score plan and returns integer, right? And it should be one of those. So table, order table. Why is it trying to do the tables everywhere? Huh? Let's see. This is on open array, right? So our sequence should work and should take those two and close here. And optional, we can give order, but we don't have to. So I'm not sure why it's not getting the sort from an array. Because this is, oh, standard algorithm. That's what it is. I forgot to import. Haha. Let's scroll down and one error just disappeared. Okay, now it's happy. Good. And now it just doesn't like our backwards index, so let's just ignore it for now. Or let's just do from, what is it? Scored plans the length minus 11 to this. And let's just wrap this because it looks so disgusting. I mean, it should work, but I still don't like it. Okay, let's try it now. Let me just make sure we don't have that conflict and doesn't calculate like 30 million properties. Where are we here? So we added that random second week. Let's remove it and let's make it normal. And let's run in release mode. Okay. Already got 1,000 valid ones. Okay. Another exception, index 5, not in 0 to 4. What? Okay, that's new. I guess that's where I'm getting the weeks or something. Somewhere down here when I'm scoring the weeks. Plans. So cleanup should be fine. Printing should be fine. Scored plans is good. Valid plan. And then we have the whole score valid. So the score valid, I have some kind of for loop in here, right? We just need to do this. Where are we getting those weeks from? Get week schedule. And we're giving it let's try that. Although this is surprising. Let's run one more time. If it will be wrong, not a big deal. can just add some logging to how many there were. Yeah, the same thing. Okay. So now it decreased. So we changed something. Okay. So on our score, we should be here. Plan weeks. Okay, so we added the weeks. Get week schedule, and I guess we're going over some stuff here. But not really. What the hell? Week and weeks count. Ah, there we go. Here we need to go 0 to here. Now it should work. Little errors. Okay, so it found some plans. So our top 10. So let's see how many are per each week. 2, bunch, 2, and bunch. Oh, that's an ugly week. What's the worst week? 2, 3, 3, 2, bunch. 2, 3, 3, 2, bunch. Okay, that's a very interesting one. Why are these are so bad? 2, 4. 4, 2, 4. Okay, so the amplitude, like the total variance, is not that bad. I see. 2, 4, 4, 2, 4. Okay, they probably all have the same score. I see. Okay. Okay, I see it working. 2, 4, 4, 2, 4. Yeah, a bunch of those. All right. That's super awesome. Just got an idea. Because sometimes it would be nice to have music in like videos or in what do you call them, live streams, you know, for when there's a break or in a stream, or I don't know, sometimes to put it on. I need to reach out to the Flashbulb. Maybe he will be fine if I would buy his music. If somebody wants some real good, listen to some real good music, the Flashbulb. I posted it on both chats. He has awesome music and he's an awesome guy, and he has an awesome YouTube channel as well. He's a guy with good opinions, I'd say, in my opinion. Okay, so we've got scoring. We can select, you know, like top 10 best plans, which look randomy, and that makes me happy. Okay, it works. Let's do that. You know, we don't want to print out the worst 10. We have top 10, and I would actually do not as a table. I would just print them as normal present. Okay. So let's just do run. And let's just wait until it finds them all. There we go. Plans look better now. It's interesting, in all those plans, the first 2 are always the same. These are all the same. Oh no. And these are all the same. What? They're all the same plans? Bob, Eve, George. And Carol, David, Eve, George, Harry. Huh. They don't differ. They're all the same. What the heck? And the other one, it worked, but why is it printing them all the same? What just happened? Present. Form plan. For each agent in the state. Do I have like a bunch of duplicates of the same plan for some reason? That would be really bad. Let me quickly check if there's something for duplicates. Sort upper band, sorted by product, reverse, merge. Merge that uses merges are assumed to be sorted if you don't wish. Oh, sort. Okay, a bunch of sorting. Duplicate. Deduplicate. Sequence utilities. And we can specify if it's sorted. Iterates through a container and checks if at least one item fulfills the predicate. Oh, that's any. Where's the apply? Deduplicate. Returns a new sequence without duplicates. Setting the option argument is sorted to true, uses a fast algorithm for the duplication, so we could do that. So 1 second, deduplicate, sorted. And that's it. So what do we need to give it? Open array, and it's sorted, and that's it. Okay. Oh, that's in sequence utils. Do we have sequence utils? Yes. So we could just try to deduplicate. Scoring time. Everything's being scored. I probably don't have to, right? So let me think. Clean up and deduplicate. And so we do valid plans is valid plans dot deduplicate and false because it's not sorted. Okay, and we're gonna print stats again. Echo after the duplication. I'll run the whole thing again, because why not? I want to see the difference now that we're doing the duplication. Quickly run through a few million iterations, 2 million, and 3 million will be finished, right? Okay, and bam, we have everything finished. So let's see. Finished. Before the duplication, we had 1100 valid plans. After the duplication, we have 213. So somehow we are adding duplicated plans. How is that possible? Something tells me I have a lot of debugging to do. But now that we have the deduplicated, we should have each different, right? I hope. There again. Oh, no, wait. This one's David. This one is Carol. This one's same here. Same here. Carol is now here. Well, Anne is here. And few variations. Okay, these are not very exciting variations, but Nonetheless, variations. I could probably figure out the, how many there are in a top score and just pick random something, right? Yeah. Okay. Makes sense. So let's do that real quick. So instead of just printing top 10, let's do something like var top 10. And this will be a sequence of scored plans. It's empty initially. So let's do while top 10 length is less than 10. We'll basically go over the thing where var I is 0. We'll start with that. So the let top plan is this. We've got top plan. Okay. And then we do var top plans with same score. Oof, we filter it like that. Okay. Why not? And then we're just gonna do shuffle top plans with same score. Yeah, and we just pick few random ones, right? So 4 I and what do you call it? 4 I and 0 to now we need to calculate how many we have left, right? So we do top 10 dot length minus this. Okay, so we iterate over those. We'll just do basically add with that score. Let's do counter, whatever. Min index. And yeah, because we need to group them, whatever. So let's do it like this. All right. Come on. Okay, that's fixed. That doesn't seem to work properly. Oh, because we need the colon. Plans with the same score. Okay, now it works. So after that, all we need to do is min index is the, we just increase it by top plans with same score length. And yeah, and that's it. And we just iterate over again. Let's try that. So we should have 10, right? Because that will happen, another iteration only if we didn't have the full 10 elements. And then we just do for top plan in top 10. And we just do that. Let's do I, comma, top plan and top 10 pairs. Okay, that should work. Let's do it one more time and we might actually get something. And if that's gonna work, we're gonna finish the stream. Because I'm an hour too late. I'm just enjoying Nim too much. As much as I don't enjoy it in Unreal, I'm kind of enjoying it here. Okay, so let's see if we have any variation here. This thing and this stay the same. Oh, we have some variation here. More variation here. More variation here. Okay. They all start with Bob Frank, Bob Frank, Bob Frank. I guess that's how it needs to stay there, right? Bob and Frank. Very interesting. Sure. Something that wouldn't start with Bob and Frank? Should have the one that it should be possible to have one that starts with uh something else here, right? Like this guy here. Bob and something. Yeah, I agree. Name is pretty awesome. If only the tooling was better, I would really enjoy it. Because right now, the Nim suggests it's just so sluggish. And I don't know. Something where it automatically imports stuff for you. Because I like exploring with, I press dot and go stuff. I know, I'm finding a lot of just you need to address things differently. Like when you work with sets, suddenly you start running into lots of different constraints because of okay, this needs to be constant, this needs to be this needs to be that. I guess something you get used to, and over time you learn. But I'm having way slower progress in learning than many other languages. Maybe not as slow as it will be with Rust, but much slower. There's lots of quirks, which is surprising for me. Drunken says, yeah, agreed, maybe if a large company got behind it and boosted its popularity. Maybe, but I think the language itself is pretty well established from the perspective of its shape, you know? From that perspective, yeah, the only thing that could improve is tooling. And oh boy, it needs that. And yeah, it needs better tooling. I'm actually thinking like, for this whole time that I'm doing stuff, I haven't reached out for a single nibble package yet. And I don't know how that works and as in, how fun that is. But for some reason, I feel like it could be improved as well. I don't know because it's kind of stored on GitHub. I don't know how easy it is to remove a package from there. All those things, I don't know. Something more fancy would be fun. I'm probably complaining. I just really like the new JSX. It's absolutely awesome. Not JSX, what the hell? JSR, JavaScript registry. The new one is awesome. Okay, so that works. We got scoring. We got top 10 plans. So I am very happy about that. Let me just run it one more time. Or let's actually run it in a situation where one of our friends, Harry, is conflicting. And let's see if it's gonna stop at 50,000 possible solutions. Bum, bum, bum. Okay, one number goes up very fast as an in progress once. Huh. Why does it stay that way? 2361. These keep growing. This doesn't decrease. I mean, increase either. What? What happened? Did it break or something? Yeah, I have some issues there. For sure that I would need to fix because we have those duplicates. Another bunch of stuff and now it just doesn't even increase the number. just keeps going forever, not doing anything. I mean, it marks them all as invalid, but by now we would have some valid, right? Especially if it's changing so much. Okay, let's stop it. I'll need to work on that more, but I mean, I will probably, the moment I clean things up a little bit and spread them apart, is going to be a little bit better. So, yep, thank you for watching on what are we going to do on Wednesday, because it's JavaScript stuff. I guess we're going to continue on the overlay for the stream, because I would like to finally have the combined chat, finish that, and then maybe make a timer so that I can just post a timer with a background, with a proper background, something that doesn't look like terminal and scare people away. So that would be another thing to add. So yeah, we're gonna continue with the chat overlay, and that will involve actually making a web server. I'll be making it in JavaScript or TypeScript because I can use the libraries for, you know, connecting things. So that will be that. And yeah, it's gonna be fun. For some reason, I'm yearning to do more of things less Nim oriented, more of the things I'm comfortable with. So I don't know. I'll see how the Unreal Engine stuff is going. I don't know if I'm gonna survive more because, oh, it's tough. It's tough. I'll try a few more weeks. But if that's not gonna go, I might switch the Monday streams from Unreal Engine to maybe something different. Maybe web stuff, maybe C# stuff. It would be fun to do some fun things from C# for a change. So yeah, that's that. The Dark Alcoholic says it will be interesting to see the JavaScript stuff. Yeah, it'll be fun because it's a little bit easier for me. It's easier for me to, you know, keep going, keep achieving something. Although when doing front end stuff, the main pain is the CSS, but I'm doing as much as I can to avoid it. So that's something that will have probably a little bit faster pace than this stuff here, where half the time I'm just scratching my head why it doesn't work. Even more of Unreal Engine. So yeah. But I'm also considering maybe doing some C# stuff. Because C# stuff, you know, is my normal daily job. This is something I coded the most in. And, you know, maybe I could do that because it's something, you know, where I can share some things as well. And another thing that I'm thinking about is that at some point I'll be redoing my, let's call it home lab, where I'll be, you know, I basically currently have little like Nomad cluster. It's similar to Kubernetes, just less work. But I want to rework it a little bit. I might have some also networking, you know, like a new router and stuff, and set it up once for all. So it'll be fun also to show on stream how to set up something like, you know, a Nomad cluster on, let's say, 3 servers so that they communicate together. They, you know, we can shut one of them down and it's gonna still continue working. Running your stuff and exposing it on to, you know, exposing is a bad word here, but, you know, allowing some network traffic from outside to, let's say, get on a website you're hosting, or use some kind of API publicly or something, you know, to self-host things, and how to do it secure as well too. So that's a few subjects I would like to touch on as well at some point. Also because I would like to learn more about it. So yeah, I'm just jumping around between a million topics, and I have so much more AI stuff that I would like to do. Oof. Yeah. I don't know. I don't have enough hours and days of week of streaming to cover all that. And then on top of that, I'll need to start working on another video, which will be probably another 20 or 30 hours of work. All right. So thank you for watching, and like and subscribe if you like the live stream and want more of that. And you can also follow me on Twitch. Yeah, you can subscribe on YouTube, follow on Twitch, and all that stuff. So again, thank you for watching. It was nice hanging out with you, the Drunk Alcoholic. And I'm looking forward to see you on Wednesday. All right, see ya.